Good morning, Montessori Academy at Belmont Green Elementary class. This is Mr. T for another astronomy lesson. Today, we're going to follow up on the lesson we had last week, which was the formation of galaxies. And we talked about how after the Big Bang, these clouds of dust and basic elements began to accrete together and spin, and that eventually that gave way to the formation of the galaxies spinning out in the cosmos. Well, those clouds of gas and elements are called nebula. And I've posted with this video some pictures of some fantastic nebula that were taken by astronomer photographers and by the Hubble Space Telescope. And we know, scientists know, that the nebula are the birthplace of stars. Well, what does that mean? Stars are basically three different kinds. There's small stars, there's medium stars, and there's large stars. And the smallest stars live the longest, and the largest stars live the shortest period of time. So stars are born, they live a lifetime, and then they die. Scientists call that process stellar nucleosynthesis, the birth and death of stars. And that's what this lesson is going to be about today. Well, here's some fun facts. Our sun is a star. It's a medium star. About 1 million Earths could fit inside of our sun, our star. That's 109 times the diameter of the Earth is the diameter of our sun. Now, the giant stars can be 10 to 100 times larger than our sun. And the supergiants might be 1,000 times larger than our sun. And of course, we have cats in the cosmos as well, as you occasionally see one walk by through the video screen. Well, all stars are basically formed from hydrogen. And what happens in the nebula is that the hydrogen molecules start to fuse together. They start to accrete. Remember, gravity pulls objects together. And when you have hydrogen atoms joining together, more and more gets sucked into that ball, if you will, of hydrogen. So the core of the star starts to heat up because when atoms come together, there's friction. That friction produces heat. Eventually, that heat, when the mass of hydrogen becomes sufficient and the weight of the star becomes sufficient, that heat bursts into nuclear fusion. It becomes a furnace. It's a major creation of energy. And then the hydrogen starts to burn up. And the hydrogen fuses into other elements. And I'm going to show you how that happens with some materials that I created some time ago. Excuse me. So this is a pictorial of our sun that I drew. And when our sun started, it was composed entirely of hydrogen. Over a process of millions and millions and millions of years, and of course we know that our sun is about 4.6 billion years old now. So about 4.6 billion years ago, our sun started this internal dynamic of nuclear fusion. And what happened is, this is Mosby. He wants a cameo. Mosby, you gotta get out of here. Excuse me. So, our sun began its life as a hydrogen star, as all stars do. And this process of nuclear fusion is so hot inside the nuclear furnace that the atoms of hydrogen fuse together, their nuclei fuse together, and you guys who've had chemistry with Mr. T understand this terminology. they fuse and it becomes helium. So the hydrogen fuses into helium. And you can see I've used different colors. Over millions of years, this nuclear fusion process continues to happen, and the helium fuses into the element of carbon. And the carbon fuses into the element of oxygen. And the oxygen, again, this takes millions and millions of years. This has been going on for 4.6 billion years already. Okay? And so the oxygen fuses into neon. And the neon fuses into magnesium. And the magnesium fuses into iron and silicon. Now things start to get really interesting in the life cycle of a star, because what happens is the final step, the stars, the iron does not fuse. So at this point in time, the star has become incredibly dense. It started as hydrogen gas, and over its lifetime of nuclear fusion, that hydrogen gas has fused into all of these elements that are contained in the star now with this core of iron that does not fuse. It does not change. But the problem is that for the star is that the pressure inside this huge ball of elements with its iron core becomes so intense, the pressure becomes so great, the heat becomes so great, and it builds up and builds up and builds up, and then eventually, boom, a supernova happens. And when the supernova happens, all the elements contained in this mature star are scattered into space. And I've drawn this little diagram to show you the elements that are burst out into the cosmos when a supernova happens and a star dies. Wow. The birth and death of stars. Astronomers believe that our star, it's a medium-sized star, will last about 13 billion years. I'm sorry, about 10 billion years, I was mistaken. And so we have about almost 5 billion years of life left on our star, our sun. And that means that it's somewhere here in the early stages of its nucleosynthesis. There's good news. And the good news is that when a star goes supernova and scatters all of these elements into outer space, new stars in the nebula begin to form. And this process of the birth and death of stars starts all over again. And the elements begin to fuse. First off, the nitrogen. And we go through this process of the formation of stars. And so all of these elements that have been scattered, the silicon, the neon, the oxygen, the carbon, all of those elements, they're star stuff. It's scattered throughout the nebula, it's scattered throughout the cosmos. And it forms, these elements form all of the new planets, the new stars, and even all the living things in the universe. So you guys, Montessori Elementary students, and your parents are made of star stuff. That's pretty cool. The birth and death of stars generates the star stuff. That's the building blocks of everything that's in the cosmos. And that's quite an exciting story that continues. This is Mr. T, signing out.